Hey Techno Studs, hopefully by this point we're getting a great understanding of spanning tree protocol, the spanning tree algorithm, bridge protocol data units. There's a few more things that we have to cover. So in this video, let's start wrapping things up and talk about a couple more aspects to the spanning tree protocol. In this video, we're going to wrap up our talk around the processes of spanning tree protocol. Then we're going to get into some status of the ports or port statuses that each of the states that the ports can be in. Then we're going to get into some timers. We'll talk about Portfast and how to bring a port up very quickly, but then we'll also talk about what a BPDU guard is for those ports that have Portfast on them. So we already know a lot about spanning tree protocol. We know a lot about spanning tree algorithm and the process that uses to communicate using BPDUs. However, one thing that we haven't talked about is how does this all get started? We've mentioned a few aspects of this throughout the videos, but let's talk a little more in depth into it. Let's say there's a switch that's brought up that hasn't spoken to on this network yet. It's just being brought up, it's just being powered up. What's going to happen is it's not going to immediately start forwarding packets. It's not going to immediately start passing information along, which is why in some of my demo videos, we saw this pause. I would make a change and then it would be quite a while before that actual change took effect. And for a lot of those times, it was because we were waiting on STP to do its thing. And what is that thing? What is it waiting for? Well, it doesn't want to forward traffic and create a loop. So it first of all starts by just listening. A switch will listen to see if anything's going on, and then it will start responding with sending its own bridge protocol data units out to see if it can generate any traffic and generate any knowledge amongst this network right here before it starts forwarding out a bunch of packets that are going to cause loops. So that's really the process. Is there's this kind of this waiting game, this wait and see what it goes. And it happens when a switch goes live, but it also happens when a port goes live. So even if you were just to plug in a single port, it doesn't start communicating right away. When a port comes live, it's going to go through several states. It's going to start out in the blocking and then start working into listening, learning, and forwarding, or go into the disabled mode. So let's talk about each one of those states. Each one of those states is going to have different functionality. For instance, perhaps it's going to receive bridge protocol data units. It will receive bridge protocol data units and process them. The next is it's going to actually send out bridge protocol data units. So it's going to form its own bridge protocol data units and send those out. Then there is the MAC table updates. This is for just the traffic going across the switch. A switch we know does learning, where it learns of MAC addresses, and then also forwarding, where it forwards onto specific ports based off of those MAC addresses. So that's the MAC address table. So is the MAC address table going to get updated? Then we see that it actually starts forwarding frames or forwarding the traffic. Really, these two aspects is what a switch is designed to do. So is it going to perform the functions of the switches? So the switch is really not fully functional until it gets to the last where it's actually forwarding frames. And what we can see is in the blocking state, we just do a simple, it receives bridge protocol data units. So the first thing it does, it says, I don't want to get too involved here. I just want to see what's happening and see how I can be part of this network and where I'm going to fit in. Then it goes into that listening mode, where a listening mode actually sends bridge protocol data units as well as receives it. So it's both sending and receiving at that point in time. So now it's fully participating in spanning tree protocol. So this it doesn't until the listening mode happens, we don't get full participation in that spanning tree protocol. Then it goes into a learning mode, and the learning mode then includes to learning the MAC addresses. And remember, that's going to the source MAC addresses. So as a frame comes into it, it'll take a look at the source MAC address, log that and the port that it comes in on into the MAC address table. So now it's updating the MAC address table. Then it goes into, that port will go into full forwarding, in which case that will, this is supposed to be MAC address table. Does it get updated? Yes. Does it forward? And that is actually supposed to be yes right there. So I'll have to change that. But now this is correct where it actually forwards as well. And then if for some reason it needs to be an alternate route, for instance, it is a redundant link, then it will go into this disabled mode where it won't participate at all. So here is a bridge protocol data unit, and something that we kind of went over real quickly before was these timers right here, these information on timers. So let's get a little more in depth into some of these. The first one that we'll take a look at is this hello timer. The hello timer is the time that in between the times that it sends out new bridge protocol data units. So in this case right here, it's 2 bytes long. We can set it. It can be set for a range, and that range could be anywhere from 1 second to 10 seconds, but the default is 2 seconds. So that's the hello timer, and it's sent out with the bridge protocol data units. And because it's sent out with there, well, whoever gets elected as the root bridge can actually set this standard for the rest of the environment and say, this is how often I'd like everyone to speak with this bridge protocol data units. The next one we should talk about is the max age timer. The max age timer is how much time a port is spent into blocking before it transitions. And so the max age timer is set by default for 20 seconds. But it can be set from anywhere from 6 seconds to 40 seconds. So if you want to speed up this process, you could go into your network and you could change that from 20 seconds as the default to 40 seconds if you want to wait longer, or down to 6 seconds if you want it to be shorter. We also have this forward delay. The forward delay is how much time it's going to be spent both in the listening and learning mode. So if you set this for 15 seconds, it's going to set it for 15 seconds in each mode. 15 seconds is the default, by the way. And so it's going to spend a total time of 30 seconds while it's in here. Now this can be set anywhere from 4 to 30 seconds, but the default once again is 15 seconds. So far now, before we ever get into the forwarding mode, we have 20 plus 30, there's 50-second delay before this port actually becomes live. That is one of the reasons for a command called Portfast. Portfast can be set up on each one of your interfaces that you choose to set it up. And the reason why we do Portfast is because that delay, the 50-second delay, can cause some problems. When you plug in a device into your network, it's expecting to have some sort of connectivity, and it goes and reaches out and tries to find a DHCP server and get a DHCP address and tries to do some things on your network. Now, if it's waiting 50 seconds, that's quite a delay before it actually can start communicating, and it possibly could even have gone over that DHCP discovery process at that point in time. So one thing that we can do is we can say, okay, we are going to set up on all access ports, all ports that are going to have end devices, so all 3 of my Pis and my demo laptop and anything else that I want, I would set up as Portfast so it could transition much faster. And then that transition, what will happen is it's going to skip some of those steps and go into sending information out much sooner. So this is a command that can help my my ports come up much faster. But I wouldn't want to put it on a port that has a switch plugged into it. Preferably, we wouldn't put it on those trunk ports. Now, because we bring these ports up much faster, if we put Portfast on one of these ports, what happens if that port does get plugged into another switch? And then it will create a loop once again, and loops are really bad from a layer 2 perspective. They cause a lot of problems with our layer 2 networks. And so we want to really mitigate against this, and that's where the Bridge Protocol Data Unit Guard comes into play. So what a BPDU Guard is we can put that on any of the ports that we have Portfast turned on. We can use this BPDU Guard to, if a BPDU comes in on that port, then it will disable that port immediately. It'll shut off that port and it won't come live. You'll have to manually get onto there and actually set up that port again, or bring it out of the disabled state. So that's BPDU Guard. We want to use Portfast on a lot of our end devices, but BPDU Guard helps guard against anything that, if it happened to get plugged into a switch, it will disable that port and we won't get a loop on our network. There you have it. We finished up talking about processes and the statuses of those ports. We talked about timers and some of the timers and how we could adjust some of those timers. We talked about Portfast and how we can bring up ports faster than just those standard timers. And then we finished things off talking about the BPDU Guard that we put on the Portfast ports, so that way we can bring up those ports even faster.